Hi, didn't see you there. Hey, while I got you here, let me ask you a question. Have you ever picked up a pine cone and noticed the particular way in which the seeds are arranged? Well, that's not by accident. See, it's actually because of something called the Fibonacci sequence in the golden ratio.
The sequence is as follows: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and so on. The numbers of the sequence may seem random, but they're really not. Every number is generated by adding the two previous numbers before it. Let's take a closer look at some hypothetical numbers. Let's say that the proportion between A and B is equal to the proportion between A plus B over A. We can then rewrite this equation as A over A plus B over A is equal to A over B. And we know that A over A is equal to 1, so we can just rewrite that as such. Let's make these numbers a little bit less hypothetical and start assigning some values. A is equal to 34 and B is equal to 21, and A plus B equals 55, all Fibonacci numbers. And with the knowledge that we have before, we know the equivalency of these numbers. A over B equals A plus B over A. This is equal to 55 over 34, which is also equal to 34 over 21 using our proportions. Both of these proportions yield a very special number, 1.618, which is also known as phi. Phi is an irrational number, just like pi. Let's revisit our hypothetical numbers. We can rewrite B over A as 1 over A over B, and now we can rewrite this equation as such. Since we know that A over B is equal to phi, we can substitute in phi for A over B, since they are the same value. Let's rewrite this equation and put it into the quadratic form. Phi squared minus phi minus 1 is equal to 0. If we take a look at our parent quadratic equation, we see that a times x squared plus or minus bx plus or minus c is equal to 0. And we know that a and b are coefficients of x, which are in this case phi. And since there is an assumed 1 in front of every variable and number, we know that a equals x, b equals -1, and c equals -1. So, using these new values, we can plug them into the quadratic formula, which yields 1 plus the square root of 5 over 2, which is also equal to phi. If we put phi into the proportion of a circle, we get a very special angle, 137.5 degrees. Plants use this angle in order to arrange their leaves, seeds, and petals in a way where they don't overlap. Plants evolve this way in order to pack the most amount of leaves, seeds, or petals into a given area.